Alright, my dears, we got a lot to do today, so I wanted to show you what we're looking at. You have 3 articles to read. The first is about how cars became the dominant form of transportation in the US, and we're reading this to help us understand where we are today and how we got there. So start out with this question and then read, and it's going to be a little weird, we're going to flip it this way, and then keep reading. You're going to answer a question at the end. Alright, then you're going to read a little bit about, this is how we got here, this is some of the problems that have arisen, so read a little bit more about our climate, some common misconceptions. If you have never experienced any of these misconceptions, great, you've had really good science in your life. If you have heard some of them, good news, I've got some of the clarifications for you there. And then you're going to answer, that's not actually a question to answer, that's just a double line. You're going to answer questions 3, 4, 5, and 6 here. They're pretty short answers. These are just things to help you think and know what to do with the information you're getting today. I don't want it to be in one ear and out the other. If you do some thinking about it, your brain will hold on to it. And so we had some problems, we invented cars, here's where we are now. Now we've got some new problems. What are our new solutions? So the third article you'll read is about hydrogen cars. So you've got questions 7 and 8 here. You'll read about hydrogen cars, and once again, it's a little weird. You're going to open it up, keep reading on the inside. And we're going to use hydrogen cars as our example for this summative. So I've got some additional chemistry for you here. I've got a notes video that will show you how to do all this, but it looks a little different from what you're seeing in my notebook now. I've sort of reorganized those pages a little bit since I made the video. So don't worry, the notes are exactly the same, but this is on the outside now, and this one is on the inside. So yeah, go ahead and watch the notes video. At the end, you can absolutely see these problems worked out. There's also a copy of this on Toddle already, but I'd like you to take a shot at these on your own once you have learned some more about this. So I'll also put up a video that walks through them. Finally, you do not need to do this part today. We'll do this in class on Thursday. So one more time, here's what you're responsible for today. Read the article on page 90 and answer questions 1 and 2. Read the article on page 91, answer questions 3, 4, 5, and 6. Read the article on page 93 or 92, answer questions 7 and 8, and then watch our video and take some notes so that you understand how hydrogen fuel cell vehicles work. All right, my dears. Good luck. You've got this. So I want to start by showing you how a hydrogen fuel cell engine works. Grab my pens. I should mention in this video, I'm going to go pretty quick, so you should feel free to pause anytime to catch up on writing or whatever it is. So a hydrogen fuel cell engine works in 3 steps. Okay? And so in the very first step, the hydrogen fuel is going to enter this engine. So that's step number 1. I'm going to put a 1 right here, and then I'm going to explain that step over here. So that hydrogen fuel enters the fuel cell. And the oxygen actually does not enter at this step. Yes, hydrogen and oxygen are the reactants in this reaction, but the oxygen is actually going to enter later. And the place that it enters is called the anode. I'm like 80% sure that's with 1 N. So I'll tell you more about anodes later, but for now you should just know the place it enters in this fuel cell is called the anode. So that's the first thing that happens. The second thing that happens is that, and so you see our H2 molecules right here, they're traveling in, and then here you'll notice something is happening with them, and what's actually happening is that they're being split. So that's step 2. We're going to write step 2 right here. The H2 fuel is separated into protons and electrons. And when we say separated into protons and electrons, a hydrogen is just 1 proton and 1 electron. So all we really mean is that we're taking the electron away from that proton. Now, how does this happen? It's complicated, but it's done by a catalyst. Word is right here, catalyst, and that happens through a number of chemical processes. This one is an inorganic catalyst, but you also have organic catalysts in your body. Catalyst just means it makes the reaction happen. So, separated by a catalyst. So that was step 2. So now we've got our protons from the hydrogen separated from our electrons. And you'll notice the protons go one way and the electrons go another. And that is step 3. Okay? In step 3, only the protons can actually go through this membrane here. So because only the protons can go through, the electrons have to go another direction. And that has to do with their charge. So because the protons are positive, they can cross the membrane. The electrons that are negative cannot. Remember, E negative means electron. So the electrons have to flow around the membrane. And the flow of electrons, we have already said, is electricity. So this is the step where electricity is created. It's this flow of electrons that creates electricity. Now, the electrons don't go somewhere, they just flow, and the battery is charged by that flow of electrons, and that battery will eventually power the motor of this electric vehicle. The electrons are returned to the fuel cell though, so they come in right here, and this is step 4. Okay? And in step 4, those electrons get reunited with their hydrogen protons, and this is when the oxygen finally comes into the picture. The oxygen enters on the other side of the fuel cell. This is called the cathode. Okay? So the oxygen enters, they all get united, and the products of the reaction are finally produced, and that's water. So, protons, electrons, and O2 unite to produce H2O. Okay? And that is the only product of this reaction is water vapor, which is very exciting. You know, compare this to a traditional engine. Traditional engines are coughing out CO2, carbon monoxide, and instead you could have a fuel cell that just produces water vapor. So that's an enormous positive for this. But there are a couple things that we need to consider if we really want to understand what's going on here. And one of those is, where does this H2 fuel come from? Because it's great if it comes from a clean source and produces only very clean, usable products. That would be great. But we do have to ask, just like we ask where does gasoline come from, we have to ask where that hydrogen fuel comes from. Good news is, you have already started learning about this today. Hydrogen fuel can be produced by a couple of methods, but one of them is electrolysis. That doesn't say produced. We're missing an O there. Squeeze it in. Produced by electrolysis. I'm not editing this, so best of luck. I believe in you. So to understand this full process, or this full supply chain, it's great to know that water vapor is produced plus electricity to power a car, but we need to go all the way back to the beginning. Just like we would ask, okay, where does that gasoline come from? Okay, we're talking about oil wells. All right, that includes a number of like ecological disasters. We need to know where that H2 fuel comes from to really understand the full picture. So to do that, you're going to close our notes here. And ta-da! And I want to show you how this reaction, this is called electrolysis. I want to show you how this reaction goes about producing that H2 fuel. So we've got a battery. We've got 2 wires coming from the battery. Doesn't matter if they're red or black. I labeled this one negative and positive. It might be the other way around. I labeled it this way because this is how you'll usually see them if you're like jump starting a car. So in this picture, we have essentially the opposite process of what goes on in a fuel cell. So this reaction is called electrolysis. And electrolysis means literally electrolysis. What does electro mean? Well, you all know it means electricity. And you might remember from biology, or maybe you didn't hear it there, lysis means to split. Sometimes you'll hear lysis, like to lyse a cell. It means to split a cell open and, well, in that case, kill it. But so we're using electricity to split something, and in this case, what we're splitting is water. So I want to show you the actual reaction that we do here. So in a hydrogen fuel cell, we use hydrogen and oxygen to produce water. In an electrolysis reaction, we do the opposite. We take water and we add electricity, and that reaction produces oxygen and hydrogen gases. Okay, and if we want to, we can balance this reaction. We see 2 hydrogens on this side, 2 oxygens on this side, but on this side, 2 hydrogens but only 1 oxygen. No problem, we can balance that. Put a 2 here. But now we've got 4 hydrogens on this side, so we need to put a 2 here. And now we're all nice and balanced. Very good. So in this reaction, we split the water and we get oxygen gas and hydrogen gas, which is great because these are both usable products for us. We can use the hydrogen for the hydrogen fuel cells. We can use the oxygen. Maybe we're going to use that for breathing apparatuses, something like that. Unclear. But I want you to know this reaction is not simple. It doesn't actually happen just like this. It actually happens in 2 stages, and those happen at 2 different locations. At the negative terminal, which we call the anode, one reaction is happening, or half the reaction is happening, and at the other side, which we call the cathode, the other half of the reaction is happening. So I want to just briefly show you how these split out. You don't need to be able to do this, but I want you to get a richer understanding of this process. So we're going to label this location A at the anode and location C at the cathode. Here's what's going on in these 2 locations. At the anode, we have water plus some electricity in the form of electrons. Now, where does this electricity come from? Well, that's what a battery is. So here's our battery, and what we've got is electrons flowing out of that battery, flowing along that wire, flowing down the anode to the water down here, and that's where we pick them up. They come in contact with the water, and as a result, that water is split into hydrogen gas, so we're going to write H2 with a little G next to it to let you know that it's a gas. And it also makes 2 moles of hydroxide. And we could put a little AQ next to this to show you that it's still in the reaction as an aqueous ion, meaning it's dissolved in the water, but I'm going to leave that be for now. So this is what's happening at the anode. Those electrons have to go somewhere, though, and so they flow carried by this hydroxide. See, there's that negative right there. It's carrying that electron. And those negative ions flow to the cathode, which is positive. They're literally attracted there. And so what's happening at the cathode? Well, I'm so glad you asked. At the cathode, we have still more water. Okay? And that water is being split, again, into oxygen, a gas specifically. That's why there's bubbles at each of these ends. We've got the hydrogen gas being produced at the anode and the oxygen gas being produced at the cathode. Okay? It's also going to split, as that water splits, it's also going to make 4 H plus ions, and those electrons are finally returned to the cathode. So they're going to go up the cathode, along the wire, all the way back to the battery. Now eventually the battery will run out because this This is not a perfect amount of electrons. Some of these do the work of separating the gases. But overall, what we see here is that electricity is splitting water into hydrogen gas and oxygen gas. And so that flow of electrons that we've modeled here, that is electricity. So we're going to add this little note. Flow of electrons equals electricity. All right. Now, if this is driving you nuts over here, do not worry. You can literally forget all of it. Here's what I need you to notice. This reaction shows that water is being split into oxygen gas and hydrogen gas. And I'm going to circle the hydrogen gas because that's what we are concerned about in this page. The oxygen gas is useful too, but the hydrogen gas is our fuel for our hydrogen fuel cell. So in this case, I have some good news for you. How is that hydrogen gas produced? Well, if we want, we can just break down water to produce it, and then theoretically, we could use the water produced by the fuel cell to produce more fuel. That's stellar. The only thing to wonder about is the power that's in this battery. That's another one of the reactants. Where did that power come from? A couple options there. So the power to make H2 fuel renewably would come from electricity, because it's in the battery. But if it's actually going to be renewable, that means it has to be solar, hydro, wind. It has to be some renewable source of electricity. By hydro, we mean hydroelectric energy, wind energy. All of these and more can be used to make renewable electricity. Now, do we actually use these? No, unfortunately. You'll learn more about this in Unit 4, but there's a lot of ways to make electricity. Some are renewable, some are not. But there is an option here. The power to make H2O renewably could come from electricity. So we at least have a renewable option. That's good news. There are some other questions though. We wanted to make this hydrogen fuel to power our fuel cell, to charge a battery, to drive an engine. Okay, and the good news is we could make it renewably. There are other ways to make it that are not renewable, and other ways to make it besides electrolysis, and those ways also may not be renewable. We'll learn more about that later in the unit. But we have to consider a little bit how efficient is this process, and is this process one that will produce, when it produces hydrogen gas, is that something we can use in a car? So we're going to do a little bit more work on this problem. So the first question we need to ask is, how efficient is this process? How many moles of hydrogen gas are we getting for every mole of H2O we react? Because if we're reacting a couple hundred moles of H2O and only getting 1 mole of hydrogen gas, that would be a problem. We don't want to use up all the water on Earth just to power a car. So let's find out. All right, my dears. All right, if you've made it here, that means you finished the notes video. Oop, I got that question on there. Don't look, do it on your own. So at this point, I'd like you to take what you've learned and see if you can answer these 4 questions below. The only tricky part here is, remember, this means 2 moles of water yields 1 mole of oxygen gas and 2 moles of hydrogen gas. I'd like you to try these questions on your own, but if you struggle, you can go take a look at the video that I'm putting up that walks you through it, or you can go to the Padlet for our online notebook and take a look at the answers to see if you got it right. These questions are definitely sort of stretching you and getting you to do some extra practice, but that feels appropriate right before summoning. So good luck. I'll see you soon. Call me over if you need help.